This is chapter 6.3, exercises 19 through 26. This section of the book, 6.3, has to do with parametric equations. Specifically in these exercises, we're going to be taking a parametric equation and eliminating the parameter, and then, of course, identifying the graph of the parametric curve. So, I did this video lesson about a year ago, but have learned some things in the calculator, so I want to make some improvements this time. The way I like to go about these normally is to take the equation in terms of x and substitute that, solving for t, substitute in what is remaining for x into the t and the y equation. So I'm going to bring down x equals 4 minus t squared. And solving for t, if we subtract 4 from both sides of this equation, we have negative t squared is equal to x minus 4. And if we divide both sides of this equation by negative 1, we have t squared is equal to, we'll say, 4 minus x. And then if we take the square root of both sides of this equation, we get t is equal to the square root of quantity 4 minus x. Now, is that the true nature? Well, no, it's not, because we have plus or minus when we solve by using the square root method. So we're going to take this plus or minus quantity, square root quantity 4 minus x, and substitute it in for this t up here. So what that gives us is y equals plus or minus the square root of quantity 4 minus x. And we can bifurcate this, because we have two functions out of this. We're going to have y equals square root of quantity 4 minus x, and also y equals negative quantity square root of 4 minus x. And now we can graph these two functions to see what our parametric equation looks like. And if I just draw an xy coordinate plane here, x, y, well, we really have a square root function that, because it's negative, is going to open to the left. It'll be 4 units to the right. So I draw off 4 units to the right. And then we have the top function here is going to come something like this. All right. And the bottom function, I'm going to draw a different color, is going to come like this. So that's generally what it's going to look like. And then as far as one other thing we try to do with parametric equations is draw in arrows in the direction of time. Well, I already drew an arrow up here for the red upper half. But if we substitute in, say, 0 for t, at time equals 0, y is equal to 0. At time equals 1, y equals 1. So we are going in this direction around the parametric curve. So this is going to be a sideways opening parabola. And it opens to the left. And then finally, if we go to our graphing calculator, I previously put in the equation here parametrically, and here it is for part 1, and we get this upper half like this, and we can go ahead and find the lower half if we set that lower unit time. In this case, I'm going to come to the left and put in, for symmetry's sake, negative 6.28, and we press enter. We see the lower half, and if we trace, menu trace, graph trace, if we go in the direction of increasing time, see time 0.3, 0.4, we're going this direction. And if we go down in time, we'll go this way, okay? So yes, the arrows are drawn in the correct direction. Next, let's go to next odd number problem 21. By the way, I'm doing the odd number problems and leave the even number problems for your edification. Same type of situation here. We have x equals t minus 3, and to solve for t, if we add 3 to both sides, we get t equals x plus 3. And this x plus 3 we can place right here, and what that's going to leave us with is y equals 2 over x plus 3. And it should be apparent that this is a rational function, and dividing by 0 is not defined in math or in algebra, so we know that the denominator of this reciprocal rational function, x plus 3, cannot equal to 0. So therefore x cannot equal negative 3 if we add 3 to both sides. So that's going to give us, I believe, a vertical asymptote. So anyway, this is what the function is. But then we have the parameter of time to deal with. And so if we want to start at, okay, 4 t equals negative 5, x is going to be equal to negative 5 minus 3 equals negative 8. So we know we're going to go from t equals negative 8, and for t equals the upper boundary, for t equals 5, x equals 5 minus 3, which equals 2. So we're going to go from x equals negative 8 to x equals 2. And we can really put a table to use for this. And if we just put in terms of x and y, all we're concerned with is we're going to start at x equals negative 8. And what I'm going to do is go up by 2's. So negative 8, negative 4, negative 2, 0, and 2. And kind of see what they are. If we substitute in for y equals negative 8, we're going to have 2 over negative 8 plus minus plus 3, which equals negative 2/5. So I'll put negative 2/5 up here next to that negative 8. For x equals negative 6, we have 2 over negative 6 plus 3, which equals negative 2/3. So we have negative 2/3 adjacent to the input value of negative 6. And for negative 4, we have 2 over negative 4 plus 3, which equals 2 over negative 1, which equals negative 2. So we'll put in negative 2. And for negative 2, we have 2 over negative 2 plus 3, which equals 2 over 1, which equals 2. So we have 2 here. We have, just going up to the right here, we have at 0, we simply have 2 over 0 plus 3, which equals 2/3. And for 2, we have 2 over 2 plus 3 equals 2/5. So here we have 2/5. And now we can graph this. And so we draw a horizontal x-axis here. This could be your x-axis. Draw a y-axis over a little bit on the right side here. Let's see, it's close enough. And then we're going to start it at x equals negative 8 and go up to 2. So negative 1, 2, negative 3, negative 4, negative 5, negative 6, negative 7, negative 8. To the right, 2, 1, 2. And then on the y-axis, I'm going to go down 2 and up 2. I think that should cover us. Okay. Let's go ahead and plot these points. We have negative 8, comma, negative 2/5. So it'll be about right there. At negative 6, we have an output value of negative 2/3, so declining slightly. And then at negative 4, at x equals negative 4, we have a y value of negative 2. And then at negative 2, at x equals negative 2, we have a y value or output value of positive 2. And then at x equals 0, we have a value of 2/3. And then at x equals 2, we have a value of 2/5. So what that's going to look like when we sketch the graph is this. Declining, declining. Now, a thing that we don't really see, but we saw our x is not equal to negative 3. What we have here is a vertical asymptote at x equals negative 3. And so here we have this, that's what that looks like here, and then from the top we're going to look something like this. And then going out here horizontally towards the horizontal. So that's what it's going to look like. And I drew a little bit left of negative 8 to the right of 2, but you can see that general shape. And we can verify that in our graphing calculator, and I've previously entered that equation here, Control I, and then add graph, parametric 3, 4, and we go up and see this parametric equation, press enter, and we see the right part of it. Well, we haven't restricted our domain according to the instructions, and doing that, we'll go back to tab. Here we are, and we're going to go from t equals negative 5, and here we're putting in negative 5 to 5. There we have it. So see, our sketch was really pretty accurate. It corresponds quite well to what we see on the graphing calculator here. So this is going to be our answer here, and it says identify the graph we would say a reciprocal function with vertical asymptote at x equals -3. That's how we would describe that. Okay, next odd number problem, 23. We have parametric equation x equals 5 cosine t and y equals 5 sine t. And so according to how we've done things in the past, we can take this first piece, x equals 5 cosine t, and we can first divide by 5. We're solving for t at this point. So we have cosine t is equal to x over 5. Okay, and how are we going to isolate and get t by itself? Well, if we take the inverse cosine, so inverse cosine, which I write cosine, looks like cosine to the power of -1, but that's notation for inverse cosine. So we're going to have, what that leaves us with on the left side is inverse cosine of cosine t equals inverse cosine of x over 5. And inverse cosine of cosine cancel out, and we have t is equal to inverse cosine of x over 5. And then we can take this inverse cosine of x over 5 and replace this t up here. And in so doing, what we remain with is y equals 5 inverse cosine, well, it's going to be 5 sine, excuse me, 5 sine of inverse cosine of x over 5. Okay, so it's going to look like that. So let's go ahead and graph that in the calculator. In our calculator page, graph. Now we're not going to graph this parametrically at this point. So we're going to say 5 sine of inverse cosine, and do that. We go to the trig page, inverse cosine of x over 5. And this is what we get here. We get half a circle with a radius of 5. And we should get a full circle, really. But let's take a look at what we're going to do with this instead. We're going to take both these equations, x equals 5 cosine t and y equals 5 sine t, and we are going to square both sides of both of these equations. Okay, so that doesn't seem like maybe necessarily simplify things, but on the left side we're going to have x squared equals 25 cosine squared t. Now this notation, cosine with the exponent here, means this whole cosine t is squared. And for this right one here, we're going to have y squared is equal to 25 sine squared t. And we could combine these two equations and have, we'll add both these. If we just add these two equations together, we're going to have x squared plus y squared is equal to 25 cosine squared t plus 25 sine squared t. And I hope you see this x squared plus y squared on the left. It should remind you of something. Yes, the equation of circle. And the right side, we're going to take our common factor from both those terms and take it out. So we have 25 times quantity cosine squared t plus sine squared t. Now, fortunately, this cosine squared t and sine squared t plus sine squared t are going to simplify to 1. So I'm going to rewrite this as x squared plus y squared is equal to 25. And 25 can be rewritten as 5 squared. So this is an equation for a circle, and that's the parent form, or basic generic standard form, is going to be quantity x minus h squared plus quantity y minus k squared is equal to r squared. So we know that our radius is 5, and what that really looks like is this. I'm going to go back to that x squared plus y squared. No, cosine squared plus sine squared. Okay, so there we have it. That's what it's going to look like. And as time goes on, you can kind of see that if we take t equal to 0, we have y equals, we have x equals 1, and t equals 0, y equals 0. If we go up to pi over 2, we're going to have cosine pi over 2 is going to be 0, but sine pi over 2 is 1. So we're going to be going in this direction. Now let me go ahead and show you this identity here. There's an identity, it's called the Pythagorean identity, which is sine squared theta plus cosine squared theta is equal to 1. And where do we see that? Well, here we have an ACP formula chart, Pythagorean identities, and this is it right here. And so this is how we were able to, when we got a common factor and ended up with quantity times quantity sine squared theta, or sine squared t plus cosine squared t, we were able to simplify that to 1. Okay, finally, for the graph of the calculator, take a look at it. If we go to get a graph page, add graph, go to menu 3-4, and go here to this equation, enter that, this is what we get. Okay, so should make sense if we trace this, menu trace, graph trace. As we increase time, we circle counterclockwise. Okay. Next, we're going to go to the last problem. At least we're going to cover in the section I said, which is 25. And it looks quite similar, doesn't it, to problem 23. And I'm not even going to bother with anything else but squaring both of these equations. So we're going to have this left one squared, x squared equals 4 sine squared t, and then we have, for this y one, we have y squared equals 4 cosine squared t. And then putting together, we have x squared plus y squared is equal to 4 sine squared t plus 4 cosine squared t. And we have, just like we had in problem 23, x squared plus y squared is equal to 4 times quantity sine squared t plus cosine squared t, and these sine squared t plus cosine squared t cancel, fall out to equal 1. So we have x squared plus y squared equals 4, which is 2 squared. So we're going to have a circle with a radius of 2. Okay, now the one thing we don't know yet is how this thing goes, because we have xy, and we know we have a circle, but we have a parameter limitation from 0 to 3 pi over 2. If we plug in 0 for t, and we plug in 0 for t, we get 2 times sine of t, and that's going to be our x value. So our x value is going to be 0, and our y value is going to be 2 cosine t is going to be 2. So we're starting right here at time equals 0. And if as we go up to say pi over 2, we're going to have 2 sine t. Our x value is going to be 2 times sine t, which in sine of pi over 2 is 1. So we're going to x equals 1 and y equals 0. So we're going to be rotating in this direction here. Okay. And if I'm not mistaken, I think we go around 3/4 of a circle, and it should be in this direction. Let's go ahead and graph this in our calculator. Okay, menu 3, 4, go up here. I'm going to go from 0 to 3 pi over 2. So 3 times pi, and we're going to divide by 2. I think that's going to get it there. Yeah, we have a rotation just as I drew it pretty much. Menu trace, graph trace. We graph increasing time. We're going this time clockwise. We're going counterclockwise on problem 23. So that really, so we'll say 3/4 of a circle with radius equals 2. That will be our answer. And I don't know if in problem 23 we actually put that here. We would have a circle. What would it be? Yeah. X squared plus y squared equals 25. So this will be circle with radius equals 5. So that's 23. And then 26, that should be a similar type of problem to both 23 and 25. Well, good luck on these, and as always, thanks for viewing.